do you think my u should be? Okay, well, anytime you're trying to make something look like a trinomial, you want a single variable in this spot right here. If that was a 14u, and if this was a u squared, then that would look like a trinomial, right? So what does my u need to be?
Oh, your u needs to be x squared plus 6.
Right, and so u will always be what's after the coefficient of the middle term. Okay? So u is going to be x squared plus 6x. Yes?
It says on the example let u be like whatever. Will it say that on the test, or do we have to figure it out?
You'll have to figure out what u is. Okay? So u squared plus 14u plus 45 equals 0.
That looks a lot easier.
And manageable.
Okay, so this has got a 1 in front, so I could even skip the box here. What multiplies to give me 45 but adds to give me 14? 9 and 5. 9 and 5. Everybody good with that? Okay, so what is u equal? You know, in this particular case, I'm going to go ahead and replace u with this right now, because so just watch this and you'll understand why I don't write this down. If I were to say u comes out to be -9, and then I go back and replace the u with an x squared, then I'm just going to have to move the 9 back over. Do you agree?
Yeah.
So if I go ahead and just plug it in right now, that'll keep the 9 on this side. It doesn't really matter either way. I'm just trying to save us a step. Okay? You'll still get the same answer whichever way you do it, providing you do it right. So I'm going to replace u with x squared plus 6x plus 9. I guess I'll be thorough for your notes. X squared and write the whole thing out plus 6x plus 5. And now I got to set each one of those equal to 0. So what will make x squared plus 6x plus 9 come out to be 0? Well, I'm going to need a factor to figure that out. What will make x squared plus 6x plus 5 equal to 0? X plus 3 times x plus 3, okay. And what if I factor this one?
Would it be 5 and 1?
5 and 1. X plus 5, x plus 1. Okay, so I'm going to end up, it looks like, with 3 answers for x. I've got x being a -5, x being a -1, and x being a -3. And this one, of course, exists twice, but you don't have to type it twice. Yes?
Do you want us to write, like, on our test, like, multiplicity too?
No, you don't have to. Everybody okay with that? -3, -5, and -1. Okay, everybody okay with example 6? Okay, example 7.
Why does everything make sense until I get by myself?
Well, that's half the battle. I know the feeling. Happened to me over the summer. And I don't know what to tell you other than just practice, practice, practice. The more you do, the better you understand. The problem with that becomes time. Okay, so clearly this one's not a common factoring problem because all 3 terms do not have something in common. It's a u substitution. How do I know what to make u?
You could replace the
It's always what comes after the coefficient. Lowest term is what you do with common factoring. You always pull out the lowest, okay? But when you're doing u substitution, the rule of thumb is going to be whatever your middle term is, replace this thing with u. Right? So what does my u equal? X to the 1/4. It's always what comes after the middle coefficient. All right, so whatever's after the middle coefficient will be your u. Okay? So if my u is equal to this, what am I going to put here? What do you think this turns out to be?
2.
Would it be u?
Remember, we're trying to make a trinomial, so if you just had to guess, what would you say it was? U squared, right? So even if you had to guess, you could probably logically think that through. Now here's why mathematically. X to the 1/2, does everybody agree that x to the 1/2 is the same thing as x to the 4th times x to the 4th? Because you would add powers, and what's a quarter plus a quarter? A half, right? So that's why that is u squared. So to be thorough for your notes, I'll write it like that. And so now you can easily see why we have a u squared there, because each of those are a u. U and u. Okay, so what multiplies to give me 6 and adds to give me -5?
Would it be,
1 and 5. Wait, no.
it'd be negative, or,
Multiplies to give me a +6 and adds to give me a -5.
I can't figure it out. Yeah.
-3 and -2, there we go. All right. And once again, at this point, you could go ahead and solve it, or you could replace the u with an x to the 4th right now. For this one, I'm going to keep that 2 on the other side anyway, so I'm going to go ahead and solve. So remember, I'm not trying to find u. What am I trying to find? So I got to replace u with x to the 1/4. Okay, everybody good with that? Okay, how do I solve that? Anybody know? How do you get rid of a 1/4 power? Maybe if I read it like this. A 1/4 power would be a 4th root. So what if I write it like that? How do you solve that? How do you get rid of a square root? By squaring it. You do a power of 4, right? How do you undo a 4th root? With a 4th power. So now I'm going to need to take, and so for the purpose of your notes and being extra thorough, I'm going to rewrite this. Okay, so now I'm taking both sides to the 4th power because a 4th power and a 4th root cancel each other out. And you get what? What is 2 to the 4th power? 16. Okay, here the 4th power and the 4th root cancel out. And you get 3 to the 4th power. Anybody know what 3 to the 4th power is? Nope. 3 times 3 times 3 times 3. That's a 9 and that's a 9, right? 9 times 9 is 81. So 3 to the 4th is 81. Okay, x equals 16, x equals 81. Everybody okay with that? Okay, so now we're done with the u substitution problems. We did 3 examples of that. Now we're ready for the last type, which is sum and difference of cubes. And there's 2 formulas for that, and they are written on that page as well. So a cubed minus b cubed and a cubed plus b cubed. Okay, so we have formulas for those. Now, those formulas are written on your handout right there. I wanted to talk about something similar that you've learned from this, like in Algebra 1. All right? So, in Algebra 1, you always did difference of squares. Does anybody remember how you do difference of squares?
Oh, it's been a long year.
Okay, well, let's see if you can do an example. If I say x squared minus 9, how do you factor that?
Well, oh, man.
And I'm just jogging your memory here. You don't have to write this down.
Like when the x's
Oh, you
cancel
just
out.
squared the whole
The
thing?
middle terms cancel out. And so that would be x minus 3 times x plus 3. Remember that?
Oh, yeah.
Or if you have, let's say you got, I don't know, how about 25x squared minus 36? That would be 5x minus 6 and 5x plus 6, right? So the formula for difference of squares, so difference of perfect squares would be a minus b and a plus b, right? So that you learned in Algebra 1. All right? College algebra, now you're learning how to do sum and difference of cubes. Now, we did not have a sum of squares. We only had a difference of squares, right? When you do cubes, there's a formula for both, for difference of cubes and for sum of cubes. And here's your formula. A minus b, a squared plus ab plus b squared. That's the formula for difference of cubes. Difference.
Oh, yeah, we kind of did this.
Yeah.
We kind of did.
Yeah, that formula was
You may have. Okay, good.
I don't remember.
All right. Now, the formula for sum of cubes. A plus b, a squared minus ab, plus b squared. That is the sum of two cubes.
Wait, we might have done this.
Okay.
Or at least one of them.
So here's one thing I want to point out to you, because here's how these things are hard, the signs are hard to remember, all right? So these letters are exactly the same as these without the third power, and then over here you have your squareds on the end, and then the A and the B are multiplied together in the middle. To remember the signs, this sign will always match this sign, so I say S for same. This sign will always be the opposite of this sign, so I say O for opposite. And no matter what, this sign will always be positive. So it spells out the word soap. Same, opposite, always positive. Same, meaning this sign is the same as this one. O for opposite. This is always the opposite of this one. And then on the end, always positive. Same, opposite, always positive. Soap. Okay? Everybody good with that? Okay? So now, let's do an example. So this is our example 8. And I have x cubed plus 27 equals 0. So in order to check and make sure it's a sum or difference of cubes problems, you have to make sure they both have cube roots. Do both of these have nice cube roots?
Yes.
In other words, I could write this as x to the third, and I can write this as 3 to the third. You agree?
That's correct.
So when I write it like that, that helps me figure out what my A and my B are. So what would my A and my B equal? X and 3. This is my A, and this is my B. I'm making it look like this. I'm making it look like this. Does everybody see this formula on your handout?
Yes.
Okay, so right now I have it written like this. My A is an X and my B is a 3. Now I have to rewrite it like this. Okay? I'm going to take this and switch it to this format. So my A is an X, so everywhere you see an A here, we're going to have an X. Everywhere you see a B, I'm going to have a what? 3. Okay. All right, so I'm going to write x cubed plus 3 cubed will equal what? X plus 3. X squared, my A is an X, so I need to do A squared. The next is a, remember this sign's the same, so this one's the opposite. So minus A times B. What do I get if I take A times B? 3x. And then on the end, I'm supposed to have a B squared. What will I get if I put a B squared on the end? A 9. Okay, now let's not forget that originally that was equal to what? 0. So if that's equal to 0,
Okay, so are you gonna eventually, the two parentheses, is there, like it's multiplication between
Yep.
them, right? Okay. that's what I
yep.
thought.
So basically now, this is what my problem looks like right now. I have changed, scoot this up. I've changed this into this. Okay, so everybody with me? I changed this into this into this. Okay, so I've got two things multiplied together and the answer is 0. What has to be true about one of those two things?
One of them has to equal 0.
Okay, either this has to equal 0 or this has to come out to be 0. What will make this come out to be a 0?
-3.
Okay? Now when you look at the second parentheses, what will make that come out to be a 0? It's a trinomial.
So you just factor it.
So I can factor it or use the quadratic formula, and let me tell you right now, these never, ever, ever factor. Okay? When you're using sum and difference of cubes, they will not factor. Okay? So, if I know right off the bat they're not going to factor, I'm not even going to try, there's nothing that will multiply to give you 9 and add to give you 3. So I'm going to use the quadratic formula to solve this thing. Okay? So my x is going to be equal to, what's the quadratic formula? Opposite of,
B
so what's the opposite of b?
positive
This b. 3 plus or minus the square root of b squared. So -3 times -3. 9 minus 4 times a. What's my a? Times c. All over 2 times a. So if I were to simplify that, I will have 3 plus or minus, then what? 9 minus, what's 4 times 9? 36. What's 9 minus 36? -27. And I might add also that whenever you're doing a sum and difference of cubes, these usually come out with an I on them, which is what I would expect to happen here. How can I break a 27 down?
3 and 3. Wait, no, don't do that. That's a bad decision.
27 is the square root of 9, and the square root of 3, and the square root of 9 is 3. And because I had a negative in there, I'm going to have an I out here. So 3I radical 3. So 3I radical 3 all over 2. So there's my other two answers for x. I can't simplify those. Nothing reduces. I can write them as two separate answers, would be about the only thing I could do. So my answers for x is equal to -3, 3 plus 3I radical 3 over 2, and 3 minus 3I radical 3 over 2. Okay?
So,
Okay, so this time we're going to do a difference of cubes problem. This is example 9, and you have 8 z cubed minus 8 equals 0. All right, so do they have nice cube roots? They do. It's to be 2, right? 2 times 2 times 2 is 8. Does everybody agree with that? Okay, so that means that I can rewrite this as 2z cubed minus 2 equals 0. So what's my A? And what's my B? So see if you agree with that, guys. No, because the formula already takes into account the negative sign for you, okay? So that's the nice thing about sum and difference of cubes. The signs are all taken care of. Your A or B will never be negative. You will always have positives here. I know that's not the case when you do quadratic formula, but for these formulas, they take care of the negative for you, okay? All right, so now I need to rewrite it using the formula. So does anybody remember what goes in the first parentheses? Right, this sign will be the same as this one, right? I forgot my little cubed here, didn't I? Okay, so this sign is always the same as this one. Here I have 3 terms. And what about this sign right here? This one's always the same. This one's always the opposite. And the one on the end is always?
Positive.
Always positive. Always positive. This one should be the opposite of what you started with, and this one should be the same. Same, opposite, always positive. Spells the word soap. Okay, so what do I put here?
put, a squared,
What's the formula say?
a
Plus A minus B.
A minus B, right? What's A?
2z,
2z. What's B?
2.
2. So 2z minus 2. Okay. What's the formula say you should put here?
2z squared.
Nope. What's the formula say?
Says a squared.
Okay, what's A?
2z.
What's 2z times 2z? 4z squared. And Joseph, everyone makes that mistake. Almost 90% of the time when people say, I got this wrong, and I go check, that's what they did. They forgot to square the 2. Okay, it's all of A is squared, not just the variable of the A, all of A. Okay, so what do I do for the middle term? What's the formula say to do? Take
Take
A times B. So if I take 2z times 2, what do I get?
4z.
4z. And then the last one,
And it's just
B squared. So 4. Right? Okay. So what would make this thing come out to be a 0?
+1.
Everybody agree with Joseph? Is it positive 1? 2 times 1 minus 2? Sure enough. Okay, now on this one right here, I'm going to use the quadratic formula. Could you factor a 4 out of that if you wanted to?
Could.
You absolutely can, but you don't have to. And why do I know immediately that I'm using the quadratic formula?
Because it's a difference. or something.
Anytime you have sum or difference of cubes, factoring does not work. There's nothing that will multiply to give you 16, but add to give you 4. Okay? All right, so quadratic formula opposite of b would be a negative 4 plus or minus the square root of b squared, which would be, what, 16? Minus 4 times 4 times 4, all over 2 times 4. Okay, so I'm going to end up with negative 4 plus or minus what? 4 times 4 times 4 is 64. What's 16 minus 64?
Negative 48.
Negative 48. All over 8. And now I've got a breakdown of 48. Anybody know what 48 will break into? The easiest one is 16 and 3. If you catch that, you made the problem much easier on yourself, because that's the number with the biggest square root. Let's say you didn't. Let's say you wanted to use 12 and 4. So you decide to go with 4 and 12. That's great, but then you got to break the 12 down again into 4 and 3. So then you end up with that, and you get a 2 times radical 3. So try and catch the high number, but if you don't, 4 radical 3 is what you would get either way. Now, since I have a negative in here, that means I'm going to have what on the outside? So negative 4 plus or minus 4 radical I 3, or 4I radical 3 over 8. So see if that makes sense to you.
Are we able to simplify the 4s and the 8 now? Or no?
Yep, so now we can simplify all 3 of these. Okay? So 1, okay, so negative 1 plus or minus I radical 3 over 2. And of course we have this answer up here, and I could write these separately as well.
So if it comes out plus or minus, we don't have to rewrite it for the answers?
It depends what they ask you for. So very possibly they may say give all the answers with separated by commas. So if they do that, you're going to say z is equal to, they'll have that, then they'll have a box here, and then you'll say 1, comma, let's see, we have negative 1 plus, what is it, I radical 3
Yeah.
over 4? Over 2? And then negative 1 minus I radical 3 over 2. So if they want you to write them separately, it'll be like that. Okay? Yeah, if they say write them as 1, then you can do that, yes. Yeah, fill out your agenda. Okay, everybody okay with that?